Hello students, welcome to Real Academy YouTube channel. Today we are going to discuss class 9th physics, that is chapter 1 numericals, that is measurement and experimentation. So in this session we are going to deal with all the numericals. So जो भी आपके problems है associated with this chapter, they are all going to be resolved one by one. So let's get started. So this is the first numerical from exercise 1A. So from this numerical, we will start with the associated problems. So chapter number 1, first problem from exercise 1A. Here it is given as the wavelength of light of a particular color is 5800 Armstrong. So wavelength is represented by lambda. So the lambda value is given as 5800 Armstrong. Okay, this is the data. Okay, so express it in nanometer and meter. So they have asked us to find the wavelength in nanometer as well as in meters. Okay, so first of all, we need to understand the unit Armstrong. So Armstrong is somewhat 10 raised to minus 10 meters. 10 raised to minus 10 meters. Okay. So Armstrong is somewhat 10 raised to minus 10 meters. So if I'll consider this lambda is equals to 5800 into 10 raised to minus 10 meters. Can I do this? Yes, because 1 Armstrong is, the value is 10 raised to minus 10 meter. Okay. So they have asked us to find, we have to express in terms of nanometer. Okay. So we have to express in terms of nanometer. Nanometer means 1 nanometer is equals to 1 into 10 raised to minus 9 meter. So how much is nanometer? 1 nano is 10 raised to minus 9 meters. Okay. So like 1 millimeter is 10 raised to minus 3 meters. 1 micrometer is 10 raised to minus 6 meter. Same way, 1 nanometer is 10 raised to minus 9 meters. Okay. So how to convert this? If I'll reduce it by minus 1, then I need to cut short this, that is lambda is equals to 580 into 10 raised to minus 9 meter. Is it okay with everyone? 580 into 10 raised to minus 9 meter. So this 10 raised to minus 9, can we replace it by nanometer? Yes, of course. So lambda, that is wavelength, is equals to 580 nanometer. Here we got our first result of A section. Okay. So how to express in nanometer? Understood one thing, one basic thing, that 1 nanometer is equals to 10 raised to minus 9 meters. Okay. So lambda is equals to 580 nanometers. Okay. So now I need to express in meter as well. So already we have expressed this term in meter, that is 5800. I'll write it again. Lambda is equals to 5800 into 10 raised to minus 10 meters. 5800 into 10 raised to minus 10 meters. I can even write it down like lambda is equals to, if I place 5.8, that means 1, 2, 3. 3 decimals will going to deduct from this, that is 10 raised to minus 7 meters. So this is a general form in terms of meter which they have asked, and this is in terms of nanometers. Hope this one, first numerical, is very easy from exercise 1A of first chapter, that is measurements and experimentations. Clear with this numerical? Okay, let us go to second problem. Okay. The size of one bacteria is 1 micrometer. Find the number of bacteria in 1 meter length. यहाँ पे पूछा है कि एक बैक्टीरिया का साइज 1 माइक्रोमीटर होता है तो 1 मीटर में कितने बैक्टीरिया होते हैं, राइट? फाइंड द नंबर ऑफ बैक्टीरिया इन 1 मीटर. So 1 bacteria is of size 1 micrometer. Then they have asked कि 1 meter is equals to how many bacterias, right? 1 meter is equals to how many bacterias, or we can simply denote it as n. Okay, how many bacterias? 1 meter में कितने bacterias होते हैं? So how we will do this? We will just cross multiply the things. That is n into 1 micrometer is equals to 1 meter into 1. Okay, so n is equals to 1 meter upon this gets divided 1 micrometer. Okay, so this is 1 meter. 1 meter upon 1 micrometer. How much is 1 micrometer? 1 into 10 raised to minus 6 meters. Okay, this is meter. Meter and meter will get cancelled. We will get 10 raised to minus 6. ऊपर जाएगा तो क्या हो जाएगा? 10 raised to 6. That is the value of n. So in 1 meter length, there are 10 raised to 6 times 10 raised to 6 bacteria present. Okay, got this numerical? That is second question. Now moving on to third one. Okay, the third question is like this. The distance of a galaxy is 5.6 into 10 raised to 25 meter. The distance of a galaxy is 5.6 into 10 raised to 25 meter. Assuming the speed of light to be 3 into 10 raised to 8 meter per second, find the time taken by light to travel this distance. ठीक है, तो यहां पे स्पीड ऑफ लाइट का वैल्यू दिया गया है 3 into 10 raised to 8 meter per second, and the distance between the galaxy, the distance of a galaxy is somewhat around 5.6 into 10 raised to 25 meter. Okay, 5.6 into 25 meter. So they have asked us to find the time taken by light to travel this distance. We know speed is equals to distance upon time, right? Right? Okay. Now what about time? Time is equals to distance upon speed. Very good. Distance upon speed. So what is distance? Distance is 5.6 into 10 raised to 25 meter upon what about speed? Speed they have mentioned here, that is 3 into 10 raised to 8 meter per second. Meter per second. Meter will get cancelled. Second will go up. Right? 10 raised to 8. So remaining term is 10 raised to 17. Okay, 5.6 into 10 raised to 17. 5.6 into 10 raised to 17. And here is 3. So 3 ones are 3 ones are, right? 3 ones are 3, get carries 2, and 3 eights are 24. So 24 again we got 2 and we will add 0. So this is 1.86. 3 6 are 18. Okay. So the final answer would be like T is equals to 1.86 into 10 raised to 17 seconds. Okay. 1.86 into 10 raised to 17 seconds. Clear? Okay. Now let us proceed further. Hope everything is cleared here, from starting from first question to second question and then third question. In first question, what they have asked, they have just given us the wavelength in Armstrong. They have asked us to find in nanometer as well as in meter. So we came to know from this question that 1 nanometer is equals to 10 raised to minus 9 meters, right? So we have expressed it in nanometer as well as in meter. Second question, they have asked the size of one bacteria is 1 micrometer. So in 1 meter, how many bacteria should acquaint? So we have calculated from this formula. So there are total 10 raised to 6 bacteria can present in 1 meter of length. Okay. And what about third question? The third question represents the distance of a galaxy is 5.6 into 10 raised to 25 meter. The whole distance of a galaxy is given here, 5.6 into 10 raised to 25 meter. Assuming speed of light as 3 into 10 raised to 8 meter per second, find the time taken by light to travel this distance. We know the formula for time is distance upon speed. We know the distance and we even know the speed, that is 3 into 10 raised to 8 meter per second. After solving, we get the answer as 1.86 into 10 raised to 17 seconds. Clear? 1.86 into 10 raised to 17 seconds. Okay. Now, next question. The wavelength of light is 589 nanometer. Again wavelength. Okay. The wavelength of light is 589 nanometer. Earlier we have seen in numerical 1, first numerical, that is 1 nanometer is equals to how many meters? 10 raised to 589 into 10 raised to how much? Minus 9 meter. So the lambda, the value of wavelength is 589 into 10 raised to minus 9 meter. This is in terms of meters. What is its wavelength in Armstrong? They have just reversed the question. In first question, they have given the data in Armstrong and they have asked us to calculate in nanometer. Now they have just reversed the question. They have given the data in nanometer and they are asking us to find in Armstrong. So it is very easy. So we know 1 Armstrong. Come on, say 1 Armstrong. 1 Armstrong. 1 Armstrong. 1 Armstrong is 10 raised to minus 10 meter. 1 Armstrong is 10 raised to minus 10 meter. See, we have got minus 9 over here. To make it minus 10, what we will do? We will add one more 0. 5890 into multiply and divide. 10 raised to minus 10 meter. 5890 into 10 raised to minus 10 meter. We know 1 Armstrong is equals to 10 raised to minus 10 meter. So can we write the value of wavelength? The value of wavelength as 5890 Armstrong. Okay. Just now we have seen 10 raised to minus 10 meter is nothing but 1 Armstrong. Okay. So the answer is lambda, that is the value of wavelength is 5890 into 10 raised to minus 10, that is 5890 Armstrong. Clear with this? Okay. Now, next question, that is it takes 8 minutes for a light to reach from the sun to the earth. Let us draw the pictorial figure so that you could understand. It takes 8 minutes for light to reach from the sun to the earth surface. This is earth. Okay. So it takes 8 minutes. It takes 8 minutes for light to reach from the sun to the earth surface. 8 मिनट लगता है sunlight को अर्थ तक पहुंचने के लिए. Okay. If speed of light is taken to be 3 into 10 raised to 8 meter per second, find the distance from the sun to the earth in kilometer. We need to find the distance from the sun to the earth in kilometer. So you have got time, you have got speed, you need to find just the distance. So we all know speed is equals to distance upon time, right? So distance is equals to speed into time. What is the speed mentioned over here? That is 3 into 10 raised to 8 meter per second. Okay. And what about time? 8 minutes. Convert it in seconds. 8 into 60. Okay. 8 into 60. 8 into 60. Okay. So how much it will be like? 3 into 6. 3 6 are 18. That is 180 into 8 into 10 raised to 8. Okay. So 18 into 8. That is 144. 0 into 10 raised to 8. Right. So this answer is in SI unit, meter. They have asked us to find the distance from the sun to the earth in kilometer. Right. Kilometer, kilometer, kilometer. So how to mention kilometer? Can I say, chalo, I'll write it once again over here. D is equals to 1.44 into 10 raised to 8 into 10 raised to 3 meter. Will that do? I have just shifted the decimal value. Okay. So 1.44 into 10 raised to 8 into 10 raised to 3. So can I say it's 1.44 into 10 raised to 8. What is 10 raised to 3? It means kilometer. So the distance is 1.44 into 10 raised to 8 kilometer. 1.44 into 10 raised to 8 kilometer. Got the idea of this sum? Here it is mentioned as the time taken from sun to the earth. The light to travel from the sun to the earth is 8 minutes and the speed is 3 into 10 raised to 8 meter per second. What is the distance? We need to represent it in kilometer form. So the simple basic question, that is distance is equal to speed into time. We have put the value of speed. We know what we are, what the data has been given, and we have mentioned the value of time, that it takes almost 8 minutes to reach the light from the sun to the earth. We have just calculated the simple calculation and we got the answer as 1.44 into 10 raised to 8 kilometer. Okay. Okay. Chalo. Let's go to next question now. 7th one. The distance of a star from the earth is 8.33 light minutes. The 7th question is like this. The distance of a star from the earth is 8.33 light minutes. Here is a new concept which we need to understand. Light minutes. What do you mean by this statement? Express the distance in meters. Okay. So one thing you need to remember is 1 light year is how much meters? Hope you have done through the theory of this chapter. So 1 light year is how much? That is 9.46 into 10 raised to 15 meter. So 1 light year is 9.46 into 10 raised to 15 meter. But they have asked us to represent, that is the distance, as 8.33 light minutes, not year. We know the value 1 light year is 9.46 into 10 raised to 15 meter. Then what about 1 light minute? 1 light year is 9.46 into 10 raised to 15 meter. Then what about 1 light minute? So 1 light minute is 1.8 into 10 raised to 10 meter. 1.8 into 10 raised to 10 meter. Getting the point? 1 light year, we need to remember, very important, mark it as important. 1 light year is 9.46 into 10 raised to 15 meter. 1 light minute is 1.8 into 10 raised to 10 meter. Then what about 1 light second? What about 1 light second? You all know this. 1 light second is how much? Or 1 light second is equal to how many meters? It's nothing but Yes, any guesses? It's nothing but 3 into 10 raised to 8 meter. 1 light second is 3 into 10 raised to 8 meter. Getting from where it is coming like? At the speed of light, 3 into 10 raised to 8 meter per second. So 1 light second is 3 into 10 raised to 8 meters. Okay. So let's come to the statement. Again, this is the important data which we need to remember, that 1 light year is equals to 9.46 into 10 raised to 15 meter. 1 light minute is equals to 1.8 into 10 raised to 10 meter. 1 light second is equals to 3 into 10 raised to 8 meters. Okay. So as according to this data, so what we understood, 8.33 light years का मतलब क्या होता है? 8.33 light years, 8.33 light years. This represents the distance. What do you mean by this? This represents the distance and express it in meters. So this represents distance, that is 8.33 light minutes. So 1 minute is how much? 8.33 into light minutes. 1 light minutes is 1.8 into 10 raised to 10. 1.8 into 10 raised to 10 meter. 8.33 into 1.8 into 10 raised to 10 meters. So if we calculate 8.33 into 1.8, we will get the value as 1.5 into how much we will get? 10 raised to 11 meter. 1.5 into 10 raised to 11 meter. Okay. From this question, very important aspect with respect to distance, that is 1 light year is equal to 9.46 into 10 raised to 15 meter. 1 light year is equals to 1.8 into 10 raised to 10 meter, and 1 light second is equals to 3 into 10 raised to 8 meter. Okay, getting this? And the distance formula is mentioned as 8.33 light minutes, and 1 light minutes, from we can take the data from here, that is 1.8 into 10 raised to 10 meters. So if I multiply 8.33 into 1.8, I'll get the value as 1.5 into 10 raised to 11 meters. Getting everyone? Okay, so these are the 7 questions from your exercise 1A. Okay, so by this we have completed a part of exercise, a part of first exercise from your first chapter, the numericals. Okay. So shall we move to next exercise, that is 1B? Okay. So this is the first question from exercise 1B, numericals. Numericals section. Okay. So this is 1B numerical section. First question. A stopwatch, this is with respect to vernier caliper, micrometer, screw gauge and all, right? A stopwatch has 10 divisions between 0 and 5 seconds. 0 और 5 seconds के बीच में there are 10 divisions. ऐसे बोल रहा है. Stopwatch has 10 divisions graduated between 0 and 5 second mark. Okay. What is its least count? What is its least count? So least count is given as value on main scale upon number of divisions. Value on main scale upon number of divisions. So what is the value of main scale? Main scale is 0 and the first value is 5. So we will take the value on main scale as 5 upon number of divisions. How many divisions between 0 and 5? So there are 10 divisions. So what is the least count? 5 upon 10. What is 5 upon 10? 0.5. So 0.5, 0.5, and this is a stopwatch. So 0.5 seconds. 0.5 seconds. This is my least count. Okay, this is my least count. Getting with this first sum. So they have asked us, the stopwatch has 10 divisions graduated between 0 and 5 S marks. What is its least count? So the least count formula is value, the ratio of value of main scale upon number of divisions. So the ratio of value of main scale, value of main scale is 5 and number of division is 10. So 5 upon 10 is 0.5 seconds. The least count is सबसे छोटा value of your any scale. तो यहाँ पे सबसे छोटा value is this much. तो इसका value कितना है वो यहाँ पे पूछा गया है, तो इसका value है 0.5 seconds. Then how we can calculate this value? Main scale upon number of division. Number of division is 10. So main scale upon 10 is 0.5 seconds. Clear with this? चलो ऐसे ही कुछ और sums करते हैं. That is second question. A vernier has 10 divisions. A vernier has 10 divisions and they are equal to 9 divisions of main scale. See, this is somewhat like main scale. How it look like main scale? This is 0, 1, 2, 3, 4, 5. This is 5. And this is 6, 7, 8, 9, 10. This is again 10. This was 5. And so on. And so on. Okay. Here one more scale is there which is known as vernier scale, in which we do have some number of divisions. So the given data has been mentioned over here. The vernier has 10 divisions. How many divisions over here? 10 divisions. So vernier scale divisions. Let I mention like this. Vernier scale division has 10 divisions. So 10 vernier scale divisions, and they are equal to 9 divisions of main scale. They are equal to 9 divisions of main scale. 9 main scale division is equals to 10 vernier scale division. 9 main scale division, 9 main scale division is equals to 10 vernier scale division. Getting? The given data is 9 main scale division is equals to 10 vernier scale division. 9 main scale division is equals to 10 vernier scale division. चलो आगे बढ़ते हैं. If the main scale is calibrated in mm, main scale MSD is calibrated in mm. That is one main scale division is 1 mm. Okay. What is its least count? What is its least count? So the least count, the formula for least count, another formula for least count, we can write it like this as well. That is 1 MSD minus 1 VSD. Okay. Even this formula also approved or correct, that is value of main scale upon number of divisions. Another form of least count is to just to write like 1 MSD minus 1 VSD. Okay. So from this, what I can say that 1 VSD here, 10 VSD is equals to, from the given data, 1 VSD is equals to, can I write it's 9 by 10 MSD? Getting my point? 1 VSD is equals to 9 by 10 MSD? Yes. So 1 MSD minus 1 VSD. Instead of 1 VSD, can I write 9 by 10 MSD? Yes. So I'll write 9 by 10 MSD. So how to calculate it? Just cross multiply 10 MSD minus 9 MSD upon 10. Okay. 10 MSD minus 9 MSD is 1 MSD by 10 MSD. What about 1 MSD? 1 MSD we know, that is 1 MSD is 1 mm. So 1 by 10 into 1 mm. So that is 0.1 mm. So the least count is 0.1 mm. Clear? Least count is 0.1 mm. So if you want to convert it into centimeter, then how you can convert? That is 0.01 centimeter. 1 millimeter is equals to 10 raised to minus 3 meter, and 1 centimeter is equals to 10 raised to minus 2 meter. Just shift one decimal point. Okay. Getting this question? Okay. So the least count is 0.01 centimeter. Okay. Third question. A microscope is provided with main scale graduated with 20 divisions in 1 centimeter. So there are 1 centimeter में 20 divisions. Okay. So 1 MSD is equals to 1 by 20 mm. Right? 1 MSD is equals to 1 by 20 centimeter. No, this one is centimeter. So 1 by 20 centimeter. 1 MSD, अगर 1 सेंटीमीटर में 20 डिविजन्स है तो 1 MSD, what is the value of this MSD? 1 MSD, one main scale division is 1 by 20 centimeter. Okay? Okay. And vernier scale with 50 divisions on it of length same as 49 divisions of main scale. Again, data has been provided over here, that is 49 main scale division is equals to 50 vernier scale division. 49 main scale division is equals to 50 vernier scale division. So what is 1 VSD? 1 VSD is 49 by 50 MSD. Okay, this is the data which we have been extracted. Okay, now find the least count of the microscope. Same question. So least count is 1 MSD minus 1 VSD. What is 1 MSD? 1 MSD is 1 MSD. Let us say 1 MSD is 1 MSD only for the time being. And what about 1 VSD? 1 VSD, can we say it is 49 by 50 MSD? So that both will be in terms of MSD only. So how much it will be going to just cross multiply? 50 MSD minus 49, that is 1 by 50 MSD. 1 by 50 MSD. Okay. So find the least count of microscope, and we know 1 MSD is how many centimeter? 1 by 20. So can I say 1 by 50 into 1 by 20 centimeter? So that is 5 2s are 10, that is 1000 centimeter, or we can say it's 0.001 centimeter. This is the value of least count, that is 0.001 centimeter. Clear? 0.001 centimeter. Getting this point? So कैसे किया हमने? यहाँ पे गिवन डेटा था, a microscope is provided with main scale graduated with 20 divisions in 1 centimeter. 1 सेंटीमीटर में कितने divisions है? 20 divisions. So can I say एक division कितना होगा? 1 by 20 centimeter. And the next data they have provided like vernier scale of 50 divisions on it of length same as that of 49 divisions of main scale. 49 divisions of main scale is equals to 50 divisions of vernier scale, right? ये vernier scale है और ये main scale है. So 49 divisions of main scale is equals to 50 divisions of vernier scale. ये given data था. So we have written as 49 main scale division is equal to 50 वर्नियर स्केल डिवीजन. ओके, सो 1 VSD कितना हो जाएगा 49/50 MSD. एंड दे हैव asked us the same thing, that is find the least count of microscope. So we know least count का formula क्या है, 1 MSD minus 1 VSD. 1 MSD is 1 MSD only as of now. 1 VSD, can I take it from here to make it everything in MSD? 1 VSD is 49/50 MSD. So 1 VSD is 49/50 MSD. Just cross multiply 50 MSD minus 49 MSD. What is 50 minus 49? 1 MSD. 1 MSD divided by 50. And we know 1 MSD is 1/20 centimeters. Okay, because the answer in your textbook is in centimeters, so we are converting it in centimeters, right? So 1 MSD is 1/20 centimeters. So 1/50, 1/20 is 1/1000 centimeters. That is 0.001 centimeters. Clear? Okay. चलो नेक्स्ट क्वेश्चन की तरफ जाते हैं. Fourth question, a boy uses a vernier caliper to measure thickness of pencil. एक पेंसिल लिया एक लड़के ने और he just wanted to measure the thickness of it. ये कितना thickness है, right? He measures it to be 1.4 mm. इसका thickness कितना मिला 1.4 mm. Very simple question. पेंसिल का thickness 1.4 mm. If the zero error of the vernier caliper is 0.02, यहां पे जीरो एरर एक और कॉन्सेप्ट है, जस्ट एक बार देख लेते क्या ही है. जीरो एरर दे हैव गिवन एज प्लस 0.02 सेंटीमीटर. व्हाट इज जीरो एरर? जब भी वर्नियर स्केल के दोनों जॉस एक दूसरे को अटैच होंगे, है ना, एंड zero of vernier scale and zero of main scale, zero of vernier scale and zero of main scale, zero of vernier scale and zero of main scale, zero of vernier scale, zero of vernier scale, vernier scale and zero of main scale and zero of main scale. जब ये दोनों कोलाइड होंगे एक दूसरे के ऊपर, एक कोइंसाइड होंगे, जीरो ऑफ मेन स्केल एंड जीरो ऑफ वर्नियर स्केल, दिस इज मेन स्केल. ओके, जीरो ऑफ मेन स्केल एंड जीरो ऑफ वर्नियर स्केल जब एक दूसरे के ऊपर कोइंसाइड होंगे, देन जीरो एरर जीरो होगा, कुछ भी नहीं होगा, राइट? जीरो एरर क्या होगा? जीरो होगा. ठीक है, सो यहां पे क्या बोल रहे हैं? जीरो एरर इज प्लस 0.02 सेंटीमीटर. दैट मींस यहां पे क्या हुआ है कि मेरा मेन स्केल के आगे वाले दूसरे पॉइंट पे वर्नियर स्केल आ गया, राइट? कि दिस हैज बीन शिफ्टेड टू हियर. यहां से शुरू हो रहा है, यहां से शुरू हो रहा है, जीरो यहां से शुरू हो रहा है इसके 2 से, राइट? सो जब ऐसे होगा, द इंस्ट्रूमेंट हैज गॉट सम एरर, दैट एरर इज नोन एज जीरो एरर. ठीक है, सो अगर बियॉन्ड आफ्टर जीरो के बाद अगर जाता है तो उसको पॉजिटिव में कंसिडर किया जाता है, और जीरो से पहले अगर ये वर्नियर स्केल इसके पहले आ जाता है, यहां से शुरू हो जाता है, देन इसको नेगेटिव एरर कंसिडर किया जाता है. ओके, सो जीरो एरर इज plus 0.02 centimeter. Okay, so what is the correct thickness of the pencil? What is the correct thickness of the pencil? What is the correct thickness of the pencil? We have got 1.44 mm, right? अब zero error plus 2 है, तो corrected reading is measured reading minus zero error. Correct reading, they have asked us to find correct thickness. So correct reading is measured reading minus zero error. So correct reading is equal to measured reading minus zero error. Correct reading is measured reading minus zero error. Okay, so this is the formula. Now let's apply. Measured reading is 1.4 mm minus zero error कितना था 0.02 centimeter, 1.4 mm, and this one is 0.02 centimeter. So we need to convert into 0.02 centimeter to meter or mm. So mm में convert करते यहीं पे कर लो. This one 10 raised to minus 2 और mm कितना हो जाएगा 10 raised to minus 3. So can I say it 0.2 mm? Very good. That is 1.4 mm minus 0.2 mm. That is 1.2 mm. The correct reading. Correct reading is 1.2 mm. Correct reading is 1.2 mm. Clear? So correct reading. So इसमें 0.02 सेंटीमीटर का एरर था. अगर उसको हम इसमें माइनस कर दे, so we will get the correct reading as 1.2 mm. Right? So the correct thickness of a pencil is 1.2 mm. Okay? So hope you have got this point, got this concept, that is zero error. ठीक है? Okay. चलो next sum. Fifth question, a vernier caliper has its main scale graduated in mm and 10 divisions on its vernier scale are equal in length to 9 mm. So 10 divisions, यहाँ पे एक डेटा हम लोग एक्सट्रैक्ट कर सकते हैं. 10 divisions on its vernier scale, 10 VSD is equals to 9 mm. So 1 VSD कितना हो जाएगा? 1 VSD is 9 by 10 mm. Right? When the two jaws are in contact, vernier scale कुछ दिखने में ऐसे दिखता है. ठीक है, और यहाँ पे रीडिंग चालू होता है, यहाँ पे वर्नियर स्केल. सो व्हेन द टू जॉस, अगर इसको नजदीक में लेके आ गए, तो द टू जॉस आर इन कॉन्टैक्ट, सब ये जीरो वाला लाइन और ये जीरो वाला लाइन वर्नियर स्केल, दिस इज डाउनवर्ड इज मेन स्केल एंड अपवर्ड इज वर्नियर स्केल. ठीक है, सो व्हेन वर्नियर स्केल का स्टार्टिंग लाइन एंड मेन स्केल का स्टार्टिंग लाइन when they are coincide with each other, then we can say the zero error is zero. Now let us see what they are trying to mention over here. When the two jaws are in contact, the zero of the vernier scale is ahead of the main scale by third division. Third division chala gaya ye aage. Here it is starting from here. It is starting from here. It is starting from here. Right? So zero error would be plus side. Okay, third division of vernier scale coincide with the main scale division. Find the least count and zero error of the vernier scale. Now first of all, let us try to find least count. Least count is 0.3 mm हो जाएगा या फिर सेंटीमीटर हो जाएगा. लेट्स सी. ठीक है, फर्स्ट वन, फाइंड द लीस्ट काउंट. लीस्ट काउंट, लीस्ट काउंट इज mm. The main scale has graduated in mm, so 1 MSD is equals to 1 mm. So least count is 1 MSD minus 1 VSD. What is 1 MSD? 1 mm minus 1 VSD. Can I say 1 VSD is 10 by 9? 9 by 10 mm? Yes. So 10 into 1, 10 minus 9 is 1 by 10 mm. So the least count is 0.1 mm. So the least count is 0.1 mm. Least count is 0.1 mm. Least count is 0.1 mm. So if I'll convert it in centimeter, 10 raised to minus 3, so that is 0.01 centimeter. Least count is 0.01 centimeter. Okay. Now, they have asked us the zero error of the vernier caliper. So, total number of vernier scale division is 10. 10 divisions on its vernier scale are equal to 9 mm. So, total number of vernier scale is, vernier divisions are 10. Okay. The zero error of the vernier scale can be calculated as third division. So 3 plus 3 into least count. So plus 3 is plus 3, and what about least count is 0.01 centimeter. So that is plus 0.03 centimeter. Okay. So this is the zero error. So what is zero error? That is plus 0.03 centimeter, plus 0.03 centimeter. Zero error is plus 0.03 centimeter. Okay. So the least count is 1 MSD minus 1 VSD. We have calculated this term and we have got 0.1 mm, and the least count is 0.01 centimeter in terms of centimeter. And what about zero error of the vernier caliper? Zero error is third division ahead of the main scale, that is plus 3 into least count. This is the actual formula, plus 3 into least count. So plus 3 into 0.01 centimeter. So the zero error is plus 0.03 centimeter. Okay. Chalo, next question. The main scale of the vernier caliper is calibrated in mm. That is 1 MSD is equals to 1 mm. Calibrated in mm. 19 divisions of main scale are equal to 20 divisions of vernier scale. So they have given one more data as 19 divisions of main scale division. 19 MSD is equals to 20 VSD vernier scale division. In measuring the diameter of a cylinder by this instrument, the main scale reads 35 divisions and fourth division of vernier scale coincide with the main scale. Find least count and radius. Find least count and radius of the cylinder. Okay. This is 1 MSD is equal to 1 mm. So the another data is given as 19 MSD is equal to 20 VSD. So what about 1 VSD? 1 VSD is equals to, can I say it's 19 by 20 MSD? So 1 VSD is equals to 19 by 20 MSD. Okay. So now they have asked us to find the least count. चलो यही पे लिख देते हैं. The least count is equals to 1. The least count is equals to 1 MSD minus 1 VSD. So what is 1 MSD? We will keep 1 MSD as 1 MSD only, minus 1 VSD. Can I say 1 VSD is 19 by 20 MSD? Okay. So 20 minus 19 is 1 by 20 MSD. So what about MSD? 1 MSD is 1 mm. 1 MSD is 1 mm. So can I say it's 1 by 20 mm? 1 by 20 is 1 by 2 is half, right? So the least count, can I say the least count is 0.5 by 10 mm. So that is 0.05 mm. Least count is 0.05 mm. So if I want to convert it in centimeter, how much it will come? 0.005 centimeter. Right? Remember what I have said. 1 mm is equals to 1 into 10 raised to minus 3 meter, and 1 centimeter is equals to 1 into 10 raised to minus 2 meter. Clear? So by this we have converted least count as 0.005 centimeter. Okay. So the next part, radius of the cylinder. Radius of the cylinder. So they have asked us to find the radius of the cylinder. So in measuring the diameter of the cylinder, they are measuring the diameter. So we will get the value as diameter and then we will divide it by 2 so that we could get the answer as for radius. Okay. So in measuring the diameter of a cylinder by the instrument, the main scale reads, it is called as MSR. Main scale reading. Okay. Main scale reading. So main scale read 35 divisions. So can I say it's 35 division? 1 MSD is 1 mm. So 35 divisions would be 35 mm. Very good. 35 mm. And fourth divisions of vernier scale coincide with the main scale. Fourth division of vernier scale. Fourth division of vernier scale. So VSR would be 4 into least count. So fourth division into least count is 0.005 centimeter. 0.005 centimeter. So how much it will be like? 4 5s are 20, right? 4 5s are 20. So can I say it's 0.02 centimeter, right? And what about this? This is mm. So 3.5 centimeter, 3.5 centimeter. Okay. Now, so this is VSR, what we are getting in centimeter. This is MSR, what we are getting in centimeter. So coincide, they have asked us to find radius. So we have got MSR, we have got VSR. So the total reading, total reading is MSR plus VSR. So what is MSR? MSR is 3.5 plus VSR. VSR is 0.02. So can I say it's 3.52 centimeter? 3.52 centimeter. What the instrument is measuring? What the instrument is measuring? The diameter. Actually, this is the value of diameter, and they have asked us to find the radius. तो radius find करने के लिए क्या करना पड़ेगा? Radius of cylinder is equals to total reading divided by 2. That is 3.52 divided by 2. 2 ones are 2 ones are 2 sevens are and again 2 6 are. That is 1.76 centimeter. This is the radius. 1.76 centimeter. The radius of cylinder. 1.76 centimeter. Clear? Hope this question is clear with you. Chalo. Next question. Next question. Seventh question. In a vernier caliper, there are 10 divisions on the vernier scale and 1 centimeter on the main scale. Is divided in 10 parts. There are 10 divisions on vernier scale and 1 centimeter on, there are 10 divisions. So VSD, vernier scale divisions कितने हैं? 10. Okay. And 1 centimeter on main scale is divided in 10 parts. 10 parts means 1 MSD. 1 MSD, 1 centimeter divided in 10 parts, centimeter. That is 0.1 centimeters. While measuring the length, the zero of the vernier lies just ahead of 1.8 centimeter. Mark and fourth division of the vernier coincide with a main scale. Find the length. First one, find the length. Length कितना होगा? So for the length, we need least count. Okay. So 1 MSD. So what about MSR then? Main scale reading. What we are getting main scale? The zero of the vernier scale just ahead of 1.8. Main scale is 1.8 centimeter. And vernier scale vernier scale reading is VSD fourth division. So we need to find here least count first. So least count is MSD, 1 MSD upon vernier scale divisions, number of divisions. So that is 0.1 upon 10. So you will get as 0.01 centimeter as least count. Okay. So VSR is fourth division, 4 into LC, that is 4 into least count is 0.01, that is 0.04 centimeter. This is the value of VSR. Okay. With the main scale, find the length. To find the length, we need total reading. So total reading is MSR plus VSR. So what is MSR? MSR is 1.8 plus, what about VSR? VSR is 0.04. So answer is 1.84 centimeter. 1.84 centimeter. Okay, this is the length what this vernier scale has been calculated as 1.84 centimeter. 1.84 centimeter. Now, the second part is if zero error of the vernier caliper is negative. Now we have got negative zero error. That means the zero of the vernier scale is beyond the main scale. Okay, the zero of the vernier scale is beyond the main scale. Is 0.02. What is the correct length? So correct reading, we know the formula. Correct reading. Correct reading is measured reading minus zero error. Measured reading minus zero error. What is the measured reading? 1.84. 1.84 centimeter. And what about the zero error? Zero error is mentioned over here, that is minus 0.02 centimeter. So this one is also in centimeter, this one is also in centimeter, therefore no problem. So that is 1.84 plus 0.02. So it will become as 1.86 centimeter. This is the correct reading. 1.86 centimeter. 1.86 centimeter. Clear? Okay. So let's move to next sum. Okay, very interesting. By the figure only you can, by looking at the scale only you can determine the value of the length. Okay. So this is main scale. This is main scale and this is vernier scale as mentioned here. Okay. Now, while measuring the length of a rod with a vernier caliper, figure 1.14. This is your question number 8 from your textbook 1B. Okay, 1.14 below shows the position of a scale. This is the position of a scale. What is the length of the rod? Come on, you tell me now. What is the length of the rod? Right? So the zero of the vernier scale, is just between this point and this point, right? So it is 3.3. The main scale reading is 3.3. And which division is coinciding with this? So let us count. First division, no. Second, no. Third, no. Fourth, no. Fifth, somewhat. And sixth is the exact count, we can say. Sixth division is somewhat exactly coinciding with the main scale. Okay. So sixth division is coinciding. So what is the length of the rod? So can I say directly by looking at the figure, can I say it is 3.36? It is 3.36 centimeter. Right? It is 3.36 0.36 centimeter. See this. It is coming between 3 and 4. So we have taken the earlier one, that is 3.3. That is MSR. Okay, what about VSR? That is 0.06. Sixth division is coinciding over here, 0.06. 1, 2, 3, 4, 5, 6. Sixth division, that is VSR as per least count is 0.06. So the total reading is MSR plus VSR, that is 3.3 plus 0.06. So the answer is 3.36 centimeter. Clear? Okay. Next question. The pitch of the screw gauge is 0.5 mm. What is pitch of the screw gauge? The screw gauge will somewhat look like this. Okay, it is somewhat look like this. Here it is the scale which we called it as main scale, and here it is the scale which we called it as circular scale. So this is my main scale, and now in screw gauge we don't have vernier scale, we have circular scale. Okay, this is thimble. And what about pitch? Pitch means after we complete one rotation with the spindle, if I complete one rotation with the spindle, how much distance it will cover, how much distance it will cover here, how much distance it will move forward, that is called a pitch. Okay, so here it is said the pitch of the screw gauge is 0.5 mm. So let us write the given data. Pitch is 0.5 mm, right? That means in one rotation it is going ahead 0.5 mm. Okay, the head scale is divided in 100 parts. The head scale is divided in 100 parts. That means CSD, circular scale division, is 100. What is the least count? Least count of the screw gauge. Least count of the screw gauge. What is least count of the screw gauge? Least count. Here for the least count formula is pitch upon circular scale division. What is pitch? 0.5 mm upon 100. That is 0.005 mm. This is the least count. This is the least count. Least count 0.005 mm. Okay, 0.005 mm. 0.005 mm. Clear? Okay. Next question. The thimble of a screw gauge has 50 divisions. The question number 10. The thimble of a screw gauge has 50 divisions. The thimble of a screw gauge has 50 divisions. That means earlier I have shown here they have 50 divisions. Okay, I'll draw it again. The thimble of a screw gauge, again it will start from 0. Okay, the thimble of a screw gauge has 50 divisions. The thimble of a screw gauge has 50 divisions. That means CSD. They have given us the data with CSD, 50 divisions. The spindle advances 1 mm when the screw is turned 2 revolutions. 2 revolution, the spindle advances 1 mm. Then 1 revolution, how many meters it will advance? 1 by 2 mm. And what about 1 revolution? It is called as pitch. As I mentioned earlier, for 1 rotation, how much linear displacement it will go ahead, that is, that distance covered is known as pitch. So for 1 revolution, half mm is going forward. That means 0.5 mm, the value of pitch. Okay. Okay. They have asked what is the pitch of the screw gauge. We have answered. The pitch of the screw gauge is 0.5 mm. What is the least count of the screw gauge? Simple. Same as last one. What is the least count? Pitch upon circular scale division. So what is your pitch value? 0.5 mm. What about circular scale division? 50 and 0.5 mm. So how you will do? 5 upon 500 mm. One's and this one is 100. So that is 0.01 mm. Least count. Least count is 0.01 mm. Clear? Clear with this? Okay. Now, coming to the next question, that is the pitch of the screw gauge is 1 mm. Pitch यहाँ पे दिया गया है. Pitch is 1 mm. So फिर से एक बार बोल देता हूं, पिच क्या होता है? एक रेवोल्यूशन पे, एक रोटेशन पे लीनियर डिस्प्लेसमेंट जितना होता है उसको पिच बोलते हैं. मतलब एक सर्कुलर रोटेशन पे जितना डिस्टेंस क्रॉस हुआ, दैट इज 1 mm, दैट इज नोन एज पिच. एंड इट्स सर्कुलर स्केल हैज 100 डिवीजन, दैट इज CSR. सर्कुलर स्केल डिवीजन, CSD. Circular scale division. How much is this? 100 divisions. Circular scale division is 100 division. In measurement of a diameter of a wire, the main scale reads 2 mm and 45th mark on the circular scale coincide with the baseline. So the MSR main scale reading is 2 mm and 45th mark. So for that purpose first we need to find the least count. So least count कितना है? That is pitch upon CSD. So pitch is 1 mm upon CSD is 100. That is 0.01 mm. Okay, so this is the least count. So CSR, circular scale reading. What is circular scale reading? 45 mark is on the baseline, coincide with the baseline, into least count. So what is least count? 45 into 0.01 mm. So how much it will be like? 0.45 mm. Okay, so find the least count. So least count we have found it like 0.01 mm and the diameter of the wire. Diameter of the wire we need total reading. So what is total reading? This is MSR plus VSR. Okay, MSR plus VSR. So what is MSR? It is given as 2 mm plus, what about VSR? VSR is 0.45 mm. 0.45 mm. So the thickness of the wire is 2.45 mm. 2.45 mm. This is total reading. Total reading, that is the diameter of the wire is 2.45 mm. 2.45 mm. 2.45 mm. If I want to convert into centimeter, this is 2.45. 1 point over here, decimal place shifts because mm is 10 raised to minus 3 and centimeter is 10 raised to minus 2. So it is 0.245 centimeter. 0.245 centimeter. Clear? Okay. Next question. When a screw gauge of least count 0.01 mm is used to measure the diameter of a wire, the reading on the sleeve is found to be 1 mm. When a screw gauge of least count 0.01, least count यहाँ पे पहले से ही दिया गया है, that is 0.01 mm is used to measure the diameter of a wire, the reading on the sleeve is found to be 1 mm and the reading on the thimble is found to be 28 division. That is MSR का reading दिया गया है 1 mm and CSR circular scale reading, formula for circular scale reading is 27th division into least count. So 27 into least count is 0.01 mm, that is 0.27 mm. Okay. Now, what is the diameter of the wire in centimeter? Diameter of the wire in centimeter. So total reading is MSR plus CSR. What is MSR? 1 mm plus CSR 0.27 mm. So what about this? Ultimately we will get 1.27 mm, but they have asked us to find in centimeter. So shift 1 point over here. So diameter of a wire will be like 0.127 centimeter. 0.127 centimeter. Okay, 0.127 centimeter. Next, if the zero error is plus 0. यहाँ पे zero error दिया गया. Zero error is plus 0.005 centimeter. What is the correct diameter? If the zero error is plus 0.005 centimeter, what is the correct diameter? So we know the reading, correct reading is equals to measure reading minus zero error. So measured reading is 0.127 minus zero error is 0.005 centimeter, and this one is also in centimeters. So if I'll minus 0.127 with 0.005, I'll get the answer as 0.127 minus 5, 2 centimeter. So this is the correct reading, 0.122 centimeter. Hope it is clear now. Next question. A screw gauge has 50 divisions on its circular scale. That means CSD is given as 50 divisions. Circular scale divisions are 50. And its screw moves 1 mm on turning by 2 rotation. That means 2 rotations is equals to 1 mm. Therefore, 1 rotation is equals to 1 upon 2 mm, which is nothing but your pitch. Okay, 1 mm is 0.5 mm. If you want to convert in centimeter, 0.05 centimeter. Okay. When the flat end of the screw is in contact with the stud, the zero of circular scale lies below the baseline, and fourth division of circular scale is in line with the baseline. So is it a positive error or negative error? Fourth division is in line with the circular scale and zero of the circular scale lies below the baseline, lies below the baseline. Always remember, if the zero of the circular scale lies below the baseline, it is positive error. If the circular scale zero lies above the baseline, it is negative error. So the zero error, first of all, let us try to find first term, that is pitch. Pitch we have got 0.05 centimeter. The least count, let us try to analyze. Least count is pitch upon CSD. Pitch is 0.05 centimeter upon CSD is 50, right? 50. So that is 5 upon 50, 100, that is 1000. 1000 means what? Centimeter. So the least count is like what? 0.001 centimeter. This is the least count. Okay. Then what about zero error then? Zero error is division fourth, that is plus 4 into least count. What is plus 4 into least count? Least count is 0.001 centimeter. So that is plus 0.004 centimeter. This is zero error. Okay, zero error is plus 0.004 centimeter. Okay, so this is the final answer. We have calculated the zero error, we have calculated the least count, and even we have calculated the pitch. Hope it is clear with everyone. Okay, now next question. Now just look at the figure. Figure 1.15 below shows the reading obtained while measuring the diameter of a wire with the screw gauge. This is screw gauge scale. This is called a circular scale. This is called circular scale. Circular scale, and this one is main scale. Okay. So how many divisions are there in circular scale? 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, right? Okay. So circular scale division, let's write over below itself. CSD. So how many divisions are there? 50. Okay. Now the screw advances by one division on the main scale when circular head is rotated once. When it is rotated once, one division is shifted. That is pitch. They have given us the data as pitch. That is one division. One division is 1 mm. For one rotation. So this is pitch, 1 mm. Okay, pitch is 1 mm. The screw advances by one division on the main scale when the circular head is rotated once. So pitch is 1 mm. Find the pitch of the screw gauge. So pitch is 1 mm. The first answer, pitch is 1 mm. Second one. Find the least count of the screw gauge. We know the least count formula, pitch upon circular scale division. Pitch is 1 mm upon circular scale division 50. So how much? 1 upon 5. So the answer is, so 1 upon 50 is nothing but 1 upon 50 is nothing but 0.02 mm. Right? Okay. Third one. The diameter of the wire. So we have got least count, we have got CSD. Now let us check out the diameter of the wire. So with the baseline 41, 42, 43, 44, 45, 46, 47. 47 divisions is coinciding. So CSR. What about CSR? CSR is 47 into LC, least count. What about least count? 47 into 0.02 mm. Okay, 0.02 mm. That is 2 7s are 14, 2 4s are 8, 9. So 90, 0.94 mm is the CSR. 0.94. 0.94 is the CSR. Okay. What about MSR? MSR, let us count 1, 2, 3, 4. MSR is 4. MSR is 4 mm. Okay. So total reading is MSR plus CSR. What is MSR? 4 mm plus, what about CSR? 0.94 mm. Okay, so the final answer is 4.94 mm. This is total reading, 4.94 mm. If I want to convert it into centimeter, then it will be like 0.494 centimeter. Okay, So the diameter of the wire is 0.494 centimeter. Hope it is clear with you all. The last sum for this exercise. Yes, the screw has a pitch equal to 0.5 mm. They have mentioned us given data as pitch is equal to 0.5 mm. What should be the number of division on its head so that as to read correct up to 0.001? That means they have mentioned us least count 0.001 millimeter with its help. So number of divisions means they are asking circular scale division. We know the least count ka formula pitch upon CSD. So we do have pitch, we do have least count. So we need to find CSD. That's it. So CSD is equals to pitch upon least count. So how much is the pitch? Is 0.5 mm. And how much is the least count? 0.001. Right? 0.001. That is, can I say it's mm only? Mm will get cancelled. So this is 5000 upon 10. So the answer is number of divisions, circular scale division is 500. So 500 division should be there so that it can, the least count would be like 0.001 mm with pitch 0.5 mm. So clear with this? So hope we have covered all the 15 numericals, all the 15 questions from the numerical sections of 1.B. So hope it will be helpful for you people, right? So let's get back to the last exercise of this chapter, that is exercise 1C. So the first question on 1C would be like, the simple pendulum complete 40 oscillations in 1 minute. 40 oscillations in 1 minute, right? Or 1 minute is equals to 60 seconds, right? Find its frequency. Find its frequency. Find its frequency. So frequency 40 oscillations. Number of oscillations 40. So number of oscillations is 40. Number of oscillation is 40 and the time required for it is 60 seconds. Time required for it is 60 seconds. So what about frequency? First point, frequency. Frequency is number of oscillation upon time. So how many number of oscillation? 40 upon 60. 40 upon 60 is 0.667 second inverse, right? 0.66 second inverse, or you can call it as hertz. Getting? Next, time period. Frequency is 0.667. So what about time period? Time period is inverse of frequency, right? So 1 upon 0.667. So 1 upon 0.667, you will get it as 1.5 seconds. So the time period is 1.5 seconds. Okay? The time period is 1.5 seconds. Clear? Okay. The time period of a simple pendulum is 2 seconds. The time period of a simple pendulum is 2 seconds. What is its frequency? Time period. Time period means to get one oscillation. That is, this is mean position. This is extreme position. So when the object or the pendulum is in mean position, starts from right extreme, again to mean position, then to left extreme, then again to one mean position, then it completes one oscillation. It completes one oscillation. Okay. So the time period they have given it as 2 seconds. What is its frequency? They have asked us frequency. We know frequency is reciprocal of time, that is 1 upon 2. 1 upon 2 is nothing but 0.5 second inverse. So this is frequency. Okay, what name is given to such pendulum? If it takes 2 seconds to complete one oscillation, then this type of pendulum is known as seconds pendulum. Okay, such a type of pendulum is known as seconds pendulum. Okay, any pendulum which takes 2 seconds to complete its one oscillation, then that pendulum is known as seconds pendulum. Chal. Next question. A seconds pendulum is taken to a place where acceleration due to gravity falls to 1/4. Acceleration due to gravity falls to 1/4. How is the time period of the pendulum affected? The time period of the pendulum, if you know students, the time period of the pendulum is given by 2 pi under root length by gravity. Okay, 2 pi under root. So earlier the time period was, let us suppose say it was T1, that is L by G, normal gravity, and the seconds pendulum means for which the time period is 2 seconds. Okay, the time period is taken to a place where acceleration falls due to gravity. Acceleration due to gravity falls to 1/4. That means new time period, the acceleration due to gravity is 1/4. 1/4 of the acceleration of the gravity. Can I say like this? Yes. How is the time period of the pendulum affected, if at all? How is the time period affected? So let us try to solve this. 2 pi, this 4 goes up, that is somewhat like 4L by G. Okay, the square root of 4 is 2. So T2 is equals to 2 into 2 pi under root L by G. So what about this 2 pi under root L by G? 2 pi under root L by G is nothing but T1. So can I say T2 is twice of T1? Okay, so it will, how is the time of the pendulum affected? It will get double of its earlier time period. Okay, it will get twice of its earlier time period, T1. Give a reason. What will be its new time period? Here they have mentioned it as it is a seconds pendulum. So we know for seconds pendulum the time period is 2 seconds. Just now we have studied in last question. Okay, so time period is 2 seconds. So for T2, 2 into T2, T1, that is 2. It will get double, that is 4 seconds. That is 4 seconds. T2 we will get it as 4 seconds. What will be its new time period? It will be 4 seconds. Okay. Chalo, next sum. Find the length of a seconds pendulum at a place where G is equals to 10 meter per second square. We know the time period ka formula, that is 2 pi under root L by G, and they have asked us to find L. So take square root on both sides. So T square is equals to 4 ka square pi square into L by G. Now substitute all the values, like it's a second pendulum means we know the value of time period is 2, it's 4. If I'll take pi ka value as 3.14 as they have said, 3.14 into 3.14 into L, and they have asked us to take G as 10. Okay. So what about the value of L then? L is 4 into 10 upon 4 into 3.14 into 3.14. Okay. So 4 and 4 will get cancelled, right? So the value of L, the value of L, the value of L, the value of L would be like, if I'll solve this whole term 3.14 into 3.14 and that 10 is divided by getting 3.14 into 3.14, the value of L, we will get it as 1.0142 meter, right? 1.0142 meter, 1.0142 meter. Okay, so they have asked us the length, to find the length. So by the formula of time period we can achieve the value of length. Okay, chalo. Next question. Compare the time period of two pendulums of length 1 meter and 9 meter. So let us say 1 meter का जो लेंथ है उसका टाइम पीरियड t1 है, उसका फॉर्मूला है 2 pi under root L by G. So can I say it's 2 pi under root 1 by G. Okay, and t2 उसका टाइम पीरियड under root 2 by L by G. So can I say it's 2 by under root 9 by G. Okay, so if I'll take the square root of 9, the square root of 9 is 3, right? That is under root 1 by G. Okay, so what about this value? 2 pi into under root 1 by G. 2 pi into under root 1 by G is t1. So can I say it's 3 times of t1? t2 is 3 times of t1. Then they have asked us to compare the time periods of two pendulums of length 1 meter. So how we will conclude? That is t1 by t2 is equals to 1 by 3. This is what the ratio implies, the comparison between t1 and t2. That is time period of two lengths of having different length as 1 and 3. Clear? Sure. Next. Now, sixth question. A pendulum completes two oscillations in 5 seconds. So here the information given as it is completing two oscillations in 5 seconds. So for one oscillation, how much time it will take? 2 by 5 seconds. That is nothing but 2.5 seconds. And this, to complete one oscillation in 2.5 seconds, is known as time period. So ultimately we have completed first part. What is its time period? So this is 2.5 seconds. If G, second part, if G is equals to 9.8, find its length. So by the formula of time period, that is T is equal to 2 pi under root L by G, we can definitely calculate the length, right? So to calculate the length, first square it on both sides. So it will come like this. Okay. So once we have square it on both sides, let us try to solve those terms. 2.5 into 2.5, and let us take G that side. So that is 9.8 upon 4 into 3.14 into 3.14. This is the value of L, and by solving this you will get the value as 1.55 meter. Okay, so by calculating a simple calculation you will get the value as 1.55 meter. Clear? Next question. The time period of two simple pendulum at a place are in the ratio of 2:1. The time period of two simple pendulum is at a ratio of 2:1. What will be their ratio of their length? So we know, if I'll take T1 by T2, we know the formula for T1 is 2 pi under root L1 by G, and T2 is 2 pi under root L2 by G. Say L1 and L2 be their respective lengths. So if I'll take the ratio, 2 pi will get cancelled, GG will get cancelled. So T1 by T2 you will get like under root L1 by LG, and the ratio of T1 by T2, here you are getting it as 2 by 1. Taking square root on both sides, you will get as, if we take square root on both sides, we will get as L1 by L2 is equals to 4:1. So this will be the ratio of their length as 4:1. Clear? Next question. It takes 2 seconds for a pendulum bob to move from mean position to one end. This is the pendulum bob, which takes 0.2 seconds for a pendulum to move from mean position to one end. This is the mean position to one end. Let us say the pendulum comes to one end like here, and it will take 2 seconds. Okay, 0.2 seconds. What is the time period? So for here to here, it will take 0.2 seconds. Again to its mean position, it will again take 0.2 seconds. And to the next end, it will again take 0.2 seconds. And it will come to again its mean position. It will take 0.2 seconds. So overall, for completing one oscillation, how much time it will take? Time period is 0.8 seconds if we add all those terms, right? Sure. Last question. How much time does the bob of a seconds pendulum take to move from one extreme of its oscillation to the other extreme? So here the question given it as कि कितना टाइम लगता है एक बॉब को एक एक्सट्रीम पोजीशन से दूसरे एक्सट्रीम पोजीशन तक जाने के लिए, right? So it's a seconds pendulum. We know seconds pendulum, to reach one side you will take 2 seconds. To complete one oscillations, the time period it will take 2 seconds. But just to complete one extreme, to have a rotation from one extreme to other extreme, how much it will take? That means it is completing only half oscillation. That means the time will be t by 2. T dash will be required by t by 2. That is 2 by 2. 1 second. Okay? From one extreme to other extreme, it will take only 1 second, as it is completing only half oscillation. Hope it is clear. So till now we have completed all the numericals of first chapter, the numericals of exercise 1A, 1B and 1C. Okay, just go through all these videos again and again. Thank you.